This problem just says solve. It means the same thing to solve the system of equations. So what we're going to do here is we're going to have to just convert these to maybe exponential equations. So what we're going to do for this one here is we're going to take this top equation and actually either solve it for x or for y. Since I have an ln on both sides, it makes it a little easier to work with. So the first thing I'm going to do is use my power rule here. This means if I have a multiplier on my log, I can take this multiplier outside and make it my exponent of whatever I'm taking the log of. So that's what I'm going to do there. It's called the power rule for logs. So that's going to result in ln of x equaling ln of y to the fifth power. Now that fifth power is only on the y, it's not on the log function itself. So now what we're going to do, since we have a log on both sides, we're just going to take each side to the e. So what I mean by that, it's going to be e to the ln of x equals e to the ln of y to the fifth. Now I picked e because the exponential e to the x is the inverse of the ln of x. So those will cancel, and those will cancel. And I actually get x equals y to the fifth. So I actually solve this for x by doing this process here. Okay, so now what I'm going to do is I'm going to take that x equaling y to the fifth, and I'm going to plug that into this other equation. So the other equation, this is the only place I have an x. So that's the only place I have to put that y to the fifth at. All right, so let's do it. So then I'm going to get log base 2, and there's my y to the fifth. 3 plus 2 log base 2 of y. Okay, so there's our equation now. So now what I'm going to do is I'm just going to bring this power to the inside of this log. So I'm going to get log base 2 y to the fifth equals 3 plus 2, log base 2 y squared. Now I'm going to subtract the log over here. So I'm going to minus log base 2 y squared to both sides. Now keep in mind here, I'm just trying to get my logs together. So then I'm going to do the same thing on this side. And then what I'm going to end up with is log base 2 y to the fifth minus log base 2 y squared equals 3. So now I have a subtraction of logs property. And what that means is if I subtract, it means I'm dividing what's inside of my logs. And the reason for that is if you think about the idea of when do I subtract exponents? I subtract them when I'm dividing. So that's why we're dividing here. It has that same structure that exponents do. So if I'm subtracting exponents, it's because I was dividing. So this is the division property of logs. So anyways, so this is going to be log base 2. And again, I'm going to have the y to the fifth on top over y squared. And I'm taking the log of all of that, and that equals 3. Now in this process now, I can simplify inside, as you can see. So I have a squared there and a fifth there, so we can do some reducing there. So this is going to be a log base 2 of, y cubed equals 3. So now what I can do next is I can either use the inverse here, or I can just use my equivalent property. So this would be 2 to the other side equals whatever I'm taking the log of. So 2 to the other side, whatever I'm taking the log of. So that's going to be 2 cubed equals y to the third. So that means y cubed equals 8, which means when I cube root both sides, I'm going to get y equals 2. So there's my answer. So now I need to get my x value, because remember what we're finding here. We're finding ordered pairs. So I'm going to plug that into this one over here. Now the reason why is because that's the easiest one to work with to get an answer. So my x is going to actually equal 2 to the 5th. So then x equals 32. So there's our answer for our x. So now we have our ordered pair. 32, 2. Final answer. So now I want you to take a look at the graph of these. Now again, this isn't necessary, but I just kind of want you to see these two equations together, because graphing these on your calculator won't work, and a lot of systems won't graph these because I just don't have an x equals or a y equals sum function. So here they are. So when you look at this one here, the pink one here, this is the ln of x equals 5 ln of y. So that's this one here, and it runs that way. And the other one runs in the same direction. They're both log functions, so as you can see, they kind of look like logs. And they also graph the x equals 32, because we found out that this point was, where they intersected was 32, 2. And then even though we didn't have the picture of this, we were still able to come up with this answer. So it's pretty cool how this all kind of works together. So again, when I'm actually solving this, just try to do whatever you can to get one expression to look like that expression in the other equation and sub it in. It's not necessarily a x equals function like we had here. So just kind of keep that in mind as you go through these. And sometimes you can be a little creative with the subs, as long as they're equal to what I'm subbing into the other one. Okay, so there it is. The answer, all we needed here was 32, 2.